All right, so in order to start off our review unit, we're going to take the time to analyze some functions. Now we're going to take a look at different properties of these functions by taking a numerical approach, which means by looking at a table, a graphical approach, meaning looking at a picture, and an algebraic approach, meaning looking at an equation. So for each one of these examples, we're going to try to classify the function, okay, give it a name, and we'll also draw a picture and specifically state as many properties as we can. Now, I might not necessarily go off of the order in which the directions state. I personally would like to graph these data points that are given to us for this function f of x in order to get a picture. So why don't you go ahead and take the time to do that. Based off these data points, plot them, and we'll connect the dots to see what type of function that we have. Now, you may not be able to plot every single point, but at least we can plot what we have. And if we were to connect the dots, it looks like we would have some type of line. And based off the picture of a line, we would classify this function f of x as linear. So we're going to try to think about what are some specific properties or characteristics of lines that we know. So to rattle off our brain, we'll take a look at domain and range. Those are good throwbacks from years past. And we'll try to take a look at some different types of equations that a linear function can have. So when you take a look at this first graph, the domain of a line, if you were to imagine dragging your pencil from left to right, you would always be touching that line. So we can say the domain is all real numbers, or use that double-stemmed R symbol to denote that idea. Very similarly for the range, we can drag our pencil low to high, and we would always be touching our line. So we would also have all real numbers for the range. Now, another characteristic when you look at this line is something that we can analyze with the continuity. Are there any holes in that line? Are there any jumps in that line? Do we have any asymptotes going on with this picture of the line? At first glance, it doesn't seem like we have any because we have a nice solid line all the way through. So linear functions, we can say, have no discontinuities. Okay, if you want to think about drawing a line, and you will never ever have to lift up your pencil, so it is continuous all the way from left to right. One other thing about a line is that it has a constant slope. And what I mean by that, you're going to hear a phrase that you probably have heard for years and years and years, is rise over run. If you were to calculate the rise and the run between 2 points on your graph, they would be the same all the way through. So it looks like our rise is down 2 and our run is right 3. So the slope between those 2 points we can say is -2/3, using the letter m, which is commonly used for slope. And if you were to pick some other easy points on your graph, or even from your table, you would probably be able to find that same slope. Now, from the table, from a numerical standpoint, we can use the slope formula between 2 points, y2 minus y1 over x2 minus x1. And if you were to pick 2 points, I'm sure you would find the same slope as -2/3. Now, one thing about a line is that we can use that slope to our advantage when it comes time to actually write the equation of that line. And different forms of lines that you've probably heard of in the past are slope intercept. We have point slope, and we have standard form. Now, slope intercept, we have to know the slope of the line, which we already do, but also the y-intercept of the graph in order to write the equation. So we can initially start off with y equals -2/3 x. And in order to find the y-intercept, we can either look at the table or the graph because we have both pieces of information. Graphically, the y-intercept looks to be at -3. But you can also tell that based off the table because the x value is 0. Notice how the y value or output is also -3 there. Now in terms of point slope and standard form, initially these are the two least common ones for students because they are more familiar with the slope-intercept form, but I swear to you that this year point slope is going to be your friend, and you'll find out when we get to Unit 2 why this is going to be your best buddy all year. So just as a refresher, point slope form is y minus y1 equals m times x minus x1, where you need to know a point and a slope. Okay, go figure. The slope is m, and the point is that x1, y1 spot. Standard form, we're not going to see that much this year, but it's still something useful to recognize. We have a line that's written as ax plus by equals c, where a, b, and c are whole numbers. Okay, no fractions, no decimals, they are whole numbers.